The metal groaned as the Sherman's engine turned over, a low rumble that swelled into a confident roar, echoing across the captured testing grounds of Kummersdorf on February 28, 1943. Hauptmann Werner Couch stood motionless, his stopwatch gripped tightly in his weathered hand, jaw clenched beneath his thin mustache. His eyes narrowed as the American tank, still bearing the painted name War Daddy 2 on its flank, accelerated smoothly across the muddy terrain, climbing a steep slope that no German Panzer had ever conquered. The impossible was happening before his very eyes. As chief mechanical engineer for the Wehrmacht's technical division, Couch had overseen the maintenance of every German tank deployed to the Eastern Front. His hands knew the inner workings of the Reich's armored fleet intimately, the temperamental engines, fragile transmissions, and complicated suspensions that broke down with alarming regularity. But this captured Sherman tank, seized in Tunisia just days earlier, had made a 350-kilometer journey to Tunis without a single mechanical failure, then survived a perilous sea journey to Germany. And now it was effortlessly climbing a 30-degree incline that would have left a Panther grinding its gears or a Tiger stranded with a broken transmission. Behind him, a cluster of German officers and engineers watched in stunned silence, their faces a mixture of admiration and dismay. One young mechanic whispered to his colleague, "It shouldn't be possible." Couch's stomach tightened into a knot of dread as the implications became clear. The Americans weren't just producing more tanks, they were producing better ones. Tanks that could travel farther, break down less, and be repaired quickly when damaged. The Sherman wasn't just a machine. It was an industrial masterpiece that represented everything the Third Reich's manufacturing philosophy was not. As the captured tank crested the hill and continued its demonstration, Couch turned toward the senior officers present and spoke words that would never appear in any official report to high command. "Gentlemen, if the Americans can build thousands of these, while we struggle to build hundreds of ours, we have already lost this war." No one at Kummersdorf that day could have predicted just how prophetic those words would become, or how the mechanical reliability of the Sherman would contribute more to Allied victory than any armor thickness or gun caliber ever could. What they witnessed that cold February morning was the culmination of American industrial might, meeting practical battlefield requirements, a revelation that would haunt German tank battalions until the war's end. And it all began with one captured tank and a group of mechanics who understood exactly what they were seeing. The future of warfare where quantity had a quality all its own, and reliability trumped theoretical perfection. This is the untold story of how American engineering pragmatism defeated German engineering perfectionism in the most crucial battlefield of all, the ability to keep fighting day after day after day. Couch had not always been so pessimistic about German armor superiority. Born in Magdeburg in 1911, Werner Couch grew up fascinated by machines. The son of a locomotive engineer, young Werner spent his childhood helping his father maintain the massive steam engines that powered Germany's rail network. By his 16th birthday, he could disassemble and reassemble an automotive engine blindfolded, a skill that would later serve him well in the Wehrmacht's technical corps. After completing his engineering studies at the Technical University of Berlin in 1933, Couch joined the newly expanding German military as a mechanical specialist. His talent for diagnosing mechanical problems seemed almost supernatural to his peers. He could identify failing components simply by listening to an engine run or feeling the vibrations through the hull. This uncanny ability brought him to the attention of General Major Ferdinand Schall, the commanding officer of the 2nd Panzer Division, who personally requested Couch be assigned to his unit in 1938. When Germany invaded Poland the following year, Couch's mechanical expertise kept the division's tanks running while other units struggled with breakdowns. By 1941, his reputation had grown to such an extent that he was transferred to the Eastern Front with a special assignment, to maximize the operational readiness of panzer units facing the brutal Russian winter. There, amid the frozen steppes, Couch learned the bitter truth about German engineering. The tanks were magnificent weapons when they worked, but they rarely worked for long. The complicated interleaved wheel suspension systems of the Tigers froze solid in the Russian mud. Engines designed for the temperate climate of Western Europe failed in the extreme cold. Transmissions cracked under the strain of the massive Tiger's weight. For every tank lost to enemy fire, 2 more were abandoned due to mechanical failures. Couch worked tirelessly, often sleeping under the tanks he was repairing, covered in grease and oil, even as temperatures plunged below -30 degrees. His dedication saved dozens of vehicles that would otherwise have been lost, earning him the Iron Cross First Class and promotion to Hauptmann. But the experience also planted the first seeds of doubt in his mind about German tank design philosophy. When he expressed concerns about the Tiger's reliability to his superiors, he was sharply reminded that his job was to fix the tanks, not criticize their design. "German engineering is the finest in the world," his commanding officer had told him dismissively. "If the tanks are failing, the fault lies with the mechanics, not the machines." Those words burned in Couch's mind as he watched his maintenance crews work 20-hour shifts, trying to keep the Panzers operational. By early 1943, Couch had been transferred back to Germany and assigned to the testing facility at Kummersdorf, where he was tasked with evaluating captured enemy tanks. The facility, located about 25 kilometers south of Berlin, was the Reich's primary testing ground for new weapons and vehicles. It was there that Couch first encountered the American Sherman that would change his perspective forever. The tank, an M4A1 captured by the 1st Panzer Regiment of the 501st Tank Battalion in Tunisia, arrived at Kummersdorf bearing the name War Daddy 2, still painted on its hull. Unlike most captured vehicles, which arrived damaged or partially destroyed, this Sherman was fully operational, having been abandoned by its crew after taking minor damage that was easily repaired by German field mechanics. What impressed Couch most was not the tank's design, which seemed unremarkable at first glance, but the fact that it had been driven from the battlefield to Tunis, a journey of over 350 kilometers, without a single mechanical failure. German tanks attempting such a journey would typically suffer multiple breakdowns requiring field repairs. The Sherman's simplicity initially struck the German engineers as crude, perhaps even primitive compared to the precision-engineered German Panzers. But as Couch began his methodical examination of the vehicle, he quickly recognized that this simplicity was its greatest strength. The engine compartment was spacious and logically arranged, making field repairs straightforward, even under combat conditions. The transmission, a component that frequently failed in German tanks, was robust and easily serviceable. Even the track system, while narrower than those on German heavy tanks, was designed for quick replacement if damaged. As the testing at Kummersdorf continued, Couch's admiration for the Sherman grew. The American tank consistently outperformed German expectations, demonstrating reliability that made the maintenance officers present exchange uncomfortable glances. One senior officer dismissed the results, suggesting that American tanks might be reliable but lacked the firepower and armor to be effective on the battlefield. Couch, however, saw beyond the specifications. He understood that a tank that could actually reach the battlefield and keep fighting day after day represented a far greater threat than a theoretically superior tank that spent most of its time being repaired behind the lines. This revelation would become even more significant as the war progressed, and the Sherman tanks began arriving on European battlefields in ever-increasing numbers. The historical context surrounding the Sherman's development and Germany's tank strategy reveals much about why this mechanical comparison proved so fateful. By 1941, the United States had observed the European conflict from a distance and drawn critical conclusions about tank warfare. Unlike Germany, which was developing increasingly massive and complex tanks like the Tiger and Panther in response to Soviet armor, American engineers focused on creating a balanced, reliable medium tank that could be mass-produced. The Sherman was the result of this philosophy, not the most heavily armored or most powerfully gunned tank, but one that delivered adequate performance in all categories while emphasizing mechanical reliability and ease of maintenance. Most importantly, it was designed from the outset for mass production using standardized parts and simplified manufacturing techniques. Germany's approach to tank design couldn't have been more different. The Nazi leadership, particularly Hitler, favored technological superiority and imposing specifications over practical considerations like reliability and ease of production. The Tiger tank, which began entering service in 1942, exemplified this philosophy. With its massive 88mm gun and thick armor, it was a formidable weapon when it worked properly, but its complexity made it a nightmare to maintain. The overlapping wheel system that gave it a smoother ride also trapped mud and ice, causing the suspension to freeze in winter conditions. The massive weight, 54 tons compared to the Sherman's 30, put tremendous strain on the engine and transmission. These engineering choices resulted in a fearsome weapon that frequently couldn't make it to the battlefield. The contrast in production capability was equally stark. While German factories struggled to produce a few hundred Tigers and Panthers each year, American factories were turning out thousands of Shermans monthly. By 1944, the United States was producing more tanks each month than Germany managed to build in the entire year. This disparity wasn't just a matter of America's larger industrial base, it reflected fundamental differences in design philosophy. The Sherman was specifically engineered for mass production, with interchangeable parts and simplified systems that could be quickly assembled by workers with minimal specialized training. German tanks, by contrast, required skilled craftsmen and precision manufacturing, creating bottlenecks in production that never could be overcome. These differences extended to the battlefield experience as well. When a Sherman was damaged, its standardized parts and straightforward design meant it could often be repaired and returned to service quickly. German tanks, with their complex systems and specialized components, frequently had to be abandoned if they couldn't be towed to a major repair facility. As the war progressed, this disparity in mechanical reliability became increasingly significant. German tank crews developed a saying, "A Tiger can destroy 10 Shermans, but only if it can reach the battlefield." The sentiment reflected a grim reality. For every Tiger lost to enemy fire, another was lost to mechanical failure. Meanwhile, Sherman tanks just kept coming, their reliability ensuring they could maintain constant pressure on German forces. The implications of this contrast were not lost on Couch and his fellow engineers at Kummersdorf, even if Germany's high command remained fixated on developing even larger and more complex tanks. The technical reports produced by the testing facility highlighted the Sherman's excellent reliability and ease of maintenance, but these practical considerations were overshadowed by specifications like armor thickness and gun caliber in the minds of military planners. This disconnect between frontline reality and strategic planning would continue to plague German armored forces until the war's end. As testing of the Sherman continued throughout March 1943, the mechanical advantages of the American tank became increasingly apparent. One demonstration in particular left a lasting impression on all present. The German test drivers were instructed to push the Sherman to its mechanical limits, running the engine at maximum RPM for extended periods, navigating extreme terrain, and performing maneuvers that would typically stress a tank's transmission to the breaking point. After 8 hours of continuous abuse, the American tank was still running smoothly, while the German Panzer IV, used as a control in the same test, had suffered a transmission failure and needed extensive repairs. Oberfeldwebel Dieter Müller, Couch's chief mechanic, spent 3 days methodically disassembling and examining every component of the Sherman's powertrain. His conclusion, delivered in a technical briefing that Couch would later describe as the most depressing meeting of my career, was unequivocal. The Americans have prioritized the aspects of tank design that actually matter in sustained combat. Their manufacturing tolerances are looser than ours, yes, but deliberately so, to allow for field repairs with minimal specialized tools. The engine compartment has been designed with maintenance in mind, unlike our tanks where replacing a simple fuel filter can require disassembling half the engine block. Müller continued, holding up a Sherman transmission component that had been tested to failure. "Look at the wear patterns on this gear assembly. They've used a lower-grade steel than we would, but they've designed it so that when it fails gradually, giving the crew warning before complete breakdown. Our transmissions fail catastrophically without warning." He then pointed to a large map on the wall showing the European and Russian fronts. Their tank will run for 300 hours before requiring major overhaul. Ours need significant maintenance every 75 to 100 hours. This means that for every one of our tanks in combat, we need to have 2 more in maintenance. The Americans can keep 3 out of 4 of their tanks operational at any given time. The room fell silent as the implications sank in. Germany was already struggling to produce enough tanks to match Allied production. If they also needed to maintain twice as many tanks in repair facilities at any given time, the numerical disadvantage would be insurmountable. Couch dismissed the meeting with a curt nod, remaining behind as the others filed out. Alone in the briefing room, he studied the disassembled components of both tanks laid out for comparison. The contrast was striking. The Sherman's parts were robust, straightforward, and designed for quick replacement, while the German equivalents were marvels of precision engineering that required specialized tools and highly trained mechanics to service. As he contemplated the components spread before him, Couch was joined by Oberst Friedrich von Holzen, a senior officer who had observed much of the testing. Unlike many of the Wehrmacht's leadership, von Holzen was a pragmatist who understood the realities of modern mechanized warfare. "Your mechanics have confirmed what I've suspected since North Africa," he said quietly. "We're fighting this war with the wrong kind of tanks." Couch nodded grimly, picking up a Sherman tracklink. "The Americans built these for war," he replied. "We built ours for engineering textbooks." Von Holzen picked up a technical report from the table. "I'll ensure this reaches those who need to see it," he said, "though I doubt it will change our course at this stage. Too many resources have been committed to the current designs." The 2 men shared a knowing look. Both understood that Germany's commitment to over-engineered tanks represented a strategic mistake that could not be corrected mid-war. The industrial capacity simply didn't exist to redesign and produce a more reliable tank in the numbers needed. They were committed to their path, for better or worse. The rising action surrounding the Sherman evaluation at Kummersdorf intensified, as April 1943 brought a new directive from the OKH, Oberkommando des Heers, German Army High Command: comparative testing against Germany's newest tank, the Panther. The Panther had been developed as a direct response to the Soviet T-34, featuring sloped armor and a high-velocity 75mm gun. It was intended to combine the firepower of the Tiger with greater mobility, and production had begun in January 1943. The Wehrmacht had high hopes for this new medium tank, believing it would help restore German armored superiority on both fronts. Couch received the order with mixed emotions. On one hand, he was curious to see how the Sherman would compare to Germany's newest tank design. On the other, he feared that the results would only confirm his growing concerns about German tank strategy. His apprehension proved well-founded. The first Panther arrived at Kummersdorf in mid-April, not from the production line as expected, but towed from a training ground after suffering a transmission failure during its initial field exercises. This inauspicious beginning set the tone for what was to follow. The comparative testing began with basic mobility trials: acceleration, turning radius, obstacle crossing, and slope climbing. The Sherman consistently matched or outperformed the Panther, not in absolute speed or climbing ability, but in reliability throughout the tests. While the German tank showed impressive capabilities in short bursts, it required constant adjustment and maintenance between trials. After just 2 days of testing, the Panther suffered a catastrophic engine fire, a common problem with early production models due to overheating. The Sherman, meanwhile, continued to operate without significant issues. Oberleutnant Gerhard Strauss, a liaison officer from the Panther production team, became increasingly defensive as the testing progressed. "The Panther is still being refined," he insisted during one particularly heated meeting. "These are teething problems that will be resolved in later production batches." Couch, who had heard similar promises about the Tiger, remained skeptical. "How many tanks will we lose learning these lessons?" he asked. "And how many crews?" The question hung uncomfortably in the air, unanswered. By the end of April, the comparative testing had painted a clear picture. The Sherman might be outgunned and underarmored compared to the Panther, but it could be counted on to actually function in combat conditions day after day. The implications of these findings reached beyond Kummersdorf. In early May, Couch was summoned to Berlin for a meeting at the Heereswaffenamt, Army Weapons Agency, where he found himself facing a panel of senior officers and production officials. The atmosphere was tense as he presented his team's findings on the Sherman's mechanical reliability compared to German tanks. His presentation was meticulous, backed by extensive data from the testing at Kummersdorf, but the reception was decidedly cold. General Major Heinrich Eberbach, who had been instrumental in the development of the Panther program, dismissed Couch's concerns. "Your data reflects early production models," he asserted confidently. "The issues you've identified are being addressed." Couch pushed back, uncharacteristically bold in this gathering of superior officers. "With respect, Herr General, we've been hearing that same assurance since the first Tigers were deployed, yet our frontline units continue to report unacceptable breakdown rates." He placed a folder on the table, field reports from the Eastern Front documenting the staggering number of tanks abandoned due to mechanical failures rather than enemy action. In the most recent operation, 22% of our tank losses were due to mechanical failure. For the Americans, that figure is less than 5%. A murmur ran through the room as the implications sank in. Oberstleutnant Franz Becker, a highly decorated tank commander who had been invited to provide frontline perspective, spoke up in Couch's defense. "What the Hauptmann is saying matches my experience in the field," he stated firmly. "I've lost more tanks to broken transmissions than to enemy fire. Meanwhile, we keep encountering the same American Sherman tanks day after day, the same individual vehicles, not just the same model. They repair them quickly and send them back into battle." The discussion grew heated as production officials defended their designs while frontline officers backed Couch's assessment. Finally, General Oberst Heinz Guderian, Inspector General of Armored Troops and one of Germany's foremost tank warfare theorists, called for silence. "Gentlemen, we must face facts," he said gravely. "We are now fighting a war of production that we cannot win if we continue our current approach." He turned to the production officials. "The Hauptmann's findings are concerning and align with what I've observed. We must simplify our designs and improve reliability." It was a significant moment, one of Germany's most respected military leaders acknowledging the strategic error in their tank design philosophy. Yet even as he spoke, Couch knew it was too late. Germany had neither the time nor the resources to change course. They would have to fight with what they had, however flawed it might be. As the meeting concluded, Guderian held Couch back with a gesture. When they were alone, the general spoke candidly. "Your report was courageous, Hauptmann. Not many would have presented such uncomfortable truths." Couch, exhausted from the confrontation, simply nodded. Guderian continued, his voice lower. "I want you to prepare a comprehensive analysis comparing all aspects of our tank program with what we know of the Allied efforts. Be thorough, be honest, and above all, be clear about what changes we can realistically implement at this stage of the war." It was an extraordinary assignment, and a tacit acknowledgement that Germany's tank strategy needed urgent reconsideration. Couch returned to Kummersdorf with a renewed sense of purpose. If he couldn't change the past decisions that had led Germany down this path, perhaps he could influence future ones. Throughout May and June 1943, he and his team conducted exhaustive comparative testing between the Sherman and various German tanks. They disassembled engines, stress-tested transmissions, timed maintenance procedures, and calculated mean times between failures. The results were compiled into what would later be known within the Wehrmacht as the Couch Report, a detailed analysis of the fundamental differences between American and German tank design philosophies and their practical implications for the war effort. The report pulled no punches. It documented how a complete engine replacement in a Sherman could be accomplished in the field in under 4 hours by a trained crew, while the same procedure on a Panther required specialized equipment and over 8 hours even in a properly equipped maintenance facility. It showed how the Sherman's standardized parts and modular design allowed for rapid repairs using components salvaged from damaged tanks, while German designs required exact replacement parts that were often in short supply. Most damningly, It calculated that for every 100 Panthers produced, only 60 to 70 would be operational at any given time due to maintenance requirements, while for the same number of Shermans, 85 to 90 would be combat-ready. The conclusion was inescapable. Germany's focus on theoretical superiority in armor and firepower had created tanks that excelled on paper but faltered in the reality of sustained combat operations. The Sherman, with its emphasis on reliability, maintainability, and mass production, represented a more effective approach to tank warfare in a global conflict. It was a painful truth that few in the German high command were prepared to accept, but one that would be proven correct as the war progressed. By July 1943, as German forces prepared for the massive tank battle that would become known as Kursk, Couch's report had reached the highest levels of the Wehrmacht. Its reception was mixed. Some officers dismissed it as defeatist, while others recognized the uncomfortable truths it contained. Guderian, true to his practical nature, ordered immediate modifications to maintenance procedures and spare parts distribution based on Couch's recommendations. But the fundamental design issues couldn't be addressed so late in the war. Germany would have to fight with the tanks they had, not the tanks they needed. For Couch personally, the report marked a turning point. His candid assessment had not endeared him to many in the military hierarchy, but his technical expertise was too valuable to ignore. In August 1943, he was reassigned to the Eastern Front with a special mission to implement improved maintenance protocols for Panzer units facing the Soviet advance. It was tacit acknowledgement that while Germany couldn't match the Allies in tank production or design philosophy, they could at least try to keep more of their existing tanks operational through better maintenance. The climax of this story unfolded not in a dramatic tank battle, but in the daily struggle to keep German armor operational as Allied forces advanced on both fronts. By early 1944, the production disparity had become overwhelming. American factories were producing Shermans at a rate German industry couldn't hope to match, even before accounting for the devastating Allied bombing campaign that increasingly targeted production facilities. For every new Tiger or Panther that reached the front, dozens of Shermans were arriving on the opposing side. The mechanical reliability gap only compounded this numerical disadvantage. Couch, now stationed with Panzer Group West in France, witnessed the consequences firsthand as Allied forces gained ground after the D-Day landings. His maintenance crews worked round the clock, performing near miracles to keep tanks running with dwindling supplies and constant air attacks on repair facilities. Despite their efforts, the operational readiness rates of German Panzer units steadily declined. By August 1944, some units reported less than 40% of their tanks as combat-ready, not from battle damage, but from mechanical failures that couldn't be repaired due to parts shortages and lack of maintenance capacity. In contrast, captured documents revealed that American armored units were maintaining operational readiness rates above 80% throughout the campaign. The Sherman's reliability advantage, which Couch had identified over a year earlier, was now playing out on the battlefield exactly as he had predicted. American tanks broke down less frequently, could be repaired more quickly when they did, and kept fighting day after day while German heavy tanks increasingly became stationary pillboxes when their engines or transmissions failed. One incident in particular crystallized the fatal flaw in German tank strategy. In September 1944, Couch was called to assess a disabled Tiger tank near the Belgian border. The massive vehicle had suffered a transmission failure, a common problem, and needed to be recovered before advancing Allied forces overran the position. The recovery team arrived with a Berger Panther, the specialized recovery vehicle, based on the Panther chassis. As they began the difficult process of hooking up the 54-ton Tiger for towing, the Berger Panther itself suffered a mechanical failure. Now they had two valuable vehicles stranded and vulnerable to air attack. In a moment of desperate innovation, Couch ordered his team to use 3 captured Shermans that had been repaired for German use to tow both disabled vehicles. The American tanks, despite their smaller size, managed to tow both German vehicles to safety, a stark demonstration of their superior reliability and robust design. As they reached the repair depot, a Luftwaffe officer who had observed the operation remarked bitterly, Perhaps we should just paint crosses on their Shermans and use those instead. The comment, meant as dark humor, contained an uncomfortable truth that Couch had recognized long ago. The Sherman's practical effectiveness trumped the Tiger's theoretical superiority in the reality of sustained warfare. By early 1945, as Allied forces pushed into Germany itself, the consequences of the Reich's tank strategy had become catastrophically clear. Production of Tigers and Panthers had all but ceased, as bombing destroyed factories and fuel shortages paralyzed what remained of the transportation network. The few tanks still operational were immobilized by lack of fuel or mechanical failures that couldn't be repaired. Meanwhile, Shermans continued to roll across the Rhine in seemingly endless numbers, their reliability ensuring they could maintain constant pressure on the collapsing German defenses. In April 1945, with Berlin under siege and the Third Reich in its final days, Couch found himself at a major repair depot outside Dresden. The facility, once a hub of German maintenance capability, now held dozens of immobilized Panzers that would never fight again, not because they had been destroyed in battle, but because they had simply broken down and could not be repaired with the resources available. Walking among these mechanical casualties, Couch encountered Müller, his former chief mechanic from Kummersdorf, now managing this last-ditch repair operation. "Do you remember that Sherman we tested?" Müller asked as they surveyed the rows of disabled German tanks. "War Daddy too?" Couch nodded, the memory still vivid despite the 2 years that had passed. "I think about it every day," Müller continued. "How different things might have been if we had built our tanks more like theirs." Couch didn't respond immediately, his gaze traveling over the proud but broken German machines surrounding them, Tigers, Panthers, and various assault guns, all engineering marvels, all now useless as the Reich crumbled. "We built the tanks we wanted," he finally said, "and they built the tanks they needed. That made all the difference." 2 days later, as Soviet forces approached Dresden, Couch ordered the remaining functional vehicles to evacuate west, hoping to surrender to American forces rather than face Soviet captivity. He remained behind with a small team to destroy sensitive documents and equipment. Among the papers he fed into the flames was his own copy of the Couch report, the detailed analysis that had predicted, with painful accuracy, how the reliability gap between German and American tanks would shape the outcome of the war. As he watched the pages burn, he reflected on how a simple difference in engineering philosophy had contributed to the defeat of what had once seemed an unstoppable military machine. The consequences of Germany's tank strategy extended far beyond the immediate military defeat. In the years after the war, as military historians analyzed the conflict, the reliability disparity between German and Allied tanks became a textbook example of how engineering decisions can have strategic consequences. The Sherman's design philosophy, privileging reliability, maintainability, and mass production over theoretical performance metrics, influenced post-war tank development around the world. Even Germany's post-war Leopard tanks reflected lessons learned from the Sherman's practical approach, emphasizing reliability alongside combat performance. Werner Couch himself survived the war, surrendering to American forces in May 1945. During his interrogation, American technical officers were surprised by his intimate knowledge of the Sherman's mechanical systems, knowledge gained during those fateful tests at Kummersdorf. One American officer reportedly asked why, given his insights, Germany hadn't developed a more reliable tank. Couch's response was simple but profound. "We were too in love with our own engineering brilliance to recognize its practical limitations." After being released from prisoner of war status in 1947, Couch returned to civilian life, eventually joining a West German automotive company, where his expertise in mechanical engineering found a more productive application. He rarely spoke about his wartime experiences, but occasionally, when pressed by colleagues, he would share one observation. "The greatest tank isn't the one with the biggest gun or the thickest armor, it's the one that can keep fighting day after day." It was a lesson he had learned the hard way, watching German tanks falter, while Shermans kept rolling across Europe. The legacy of the Sherman tank extends beyond its direct military impact. Its design philosophy, emphasizing reliability, maintainability, and mass production, has influenced military procurement and engineering across many fields. Modern combat vehicles still balance the same factors that defined the Sherman Tiger comparison: theoretical performance versus practical effectiveness, complexity versus reliability, and quality versus quantity. In most cases, successful designs have followed the Sherman's example rather than the Tiger's, recognizing that a weapon system's actual contribution to victory depends more on its availability and sustained performance than on its peak capabilities. For the soldiers who fought in World War II, these engineering considerations translated directly into survival and victory. American tank crews, while often outgunned by their German opponents, could count on their vehicles to function reliably day after day. German crews, manning technically superior but mechanically fragile machines, faced not only the enemy but the constant anxiety of potential breakdown. As one German Panzer commander wrote after the war, "We had the better tanks, but they had tanks that worked." This simple truth underpinned one of history's most significant lessons in military engineering. The story of War Daddy 2 and the German mechanics who examined it reminds us that warfare is not just a contest of weapons, but of systems, industrial, logistical, and engineering systems that must work together to deliver combat power where and when it's needed. The Sherman tank, with its balanced design and exceptional reliability, represented a system that worked. The Tiger and Panther, for all their impressive specifications, represented systems that faltered when subjected to the sustained demands of global warfare. As we reflect on this history, we might wonder what Hedman Couch would think of modern military procurement debates, where performance specifications often dominate discussions of cost and reliability. Perhaps he would remind us of the lesson he learned at Kummersdorf, that the most fearsome weapon on paper means nothing if it cannot reach the battlefield and keep fighting. In the end, the Sherman's greatest victory wasn't won by its gun or its armor, but by its engine, an engine that kept running while others failed, carrying its crew forward day after day until victory was secured. Would you have recognized this crucial difference if you had stood beside Couch, watching that captured Sherman climb an impossible slope at Kummersdorf? Would you have seen beyond the specifications to understand that reliability would ultimately matter more than theoretical superiority? This question echoes through military history, challenging us to look beyond impressive capabilities to the practical realities that determine success or failure in conflict. The Sherman tank stands as a testament to the importance of getting those practical realities right, a lesson written not in technical manuals, but in the outcome of history's largest conflict. Share this story so others remember what engineering courage really means: the courage to prioritize what actually works over what merely impresses on paper. In a world increasingly dominated by complex technology, the humble Sherman still has much to teach us about the true nature of effectiveness.